Hello and welcome back to the lab. Today on the bench we have another set of equipment destined to go down to the makerspace in Tennessee. So this will be adding to the Greeneville makerspace repaired equipment inventory. We have one, possibly two, RCA Ohms WV77Es. I believe these are some VTVMs. They are in rather rough shape, but we'll see what we can do about that in this episode. So the question now is, which one should we start with first? This one, just from quick glance, has a bit more rust on it, and I have yet to get the sandblaster in the lab. I do have a we have lots of plans going on for future videos and things like that, and getting further and further down the path of restorations for some of this equipment. I'd love to get into repainting some chassis and things like that, but that is strictly a money problem. More dollars are flowing out than flowing in. Well, we'll just say the acquisition list is long. So we'll work through it, and everything will grow in its own time. So I'm not too worried about that. But this one, the meter face is a little bit rougher. So this one's got an easier to read meter face, but this one has a better chassis, and that one has the handle on it. So I think we'll attack the meter face first. I do have some polishing wheels for the drill press. We will buff out this meter face, make it look nice again. I can tell the meter's off right now. The mechanical zero of the needle is off and not correct, so that will need to be corrected. Hopefully our meter movements are okay. I have not been running a very good out-of-the-box meter movement average at the moment. It's been had to repair a lot of needle meters recently. Fortunately, the HPs that we did in a previous video, they were fine, so didn't need to work on those movements. Although I did just get done replacing a needle movement on a Simpson 260 because the plastic support structure of the mechanical zero just broke. The older ones were metal. I like the metal ones. I think it was a much better design, but the plastic one shattered. So we had to get that fixed. Well, let's get this on, get it cracked. Let's check the meter movement. We can do that on the ohms range, and we'll crack it open. There is a battery in these meters, even though they have an electrical cord. Those batteries tend to off-gas and leak and do all kinds of damage to the inside of the meter, so hopefully we don't run into that. Definitely, if you're going to decommission one of these meters and take it out of service, you definitely want to take that battery out. It does not do them any favors over time. This is a more modern version. These are 4mm banana jacks, which that's actually kind of small for a 4mm banana jack, but yes, very loose. The older ones had a circular connection here that I'm not too much of a fan of. I like swapping those out to BNCs, but I also have some probes that I'll need to swap out to BNCs as well, just to make everything work correctly. Now, enough of me talking. Let's get this one off the bench, that one opened up, and let's see what we're getting into. Okay, we have moved the camera off to the side, so you guys are over my right shoulder. Let's see what we have. Oh boy. Oh. Yikes. Well, that battery needs to go. It's actually blown open. Wow. I have not seen a battery that bad in a while. We do have a VTVM. Here's our two tubes. This cap needs to be replaced for sure. Here's our two adjustment points. Standard switch. There might be some battery damage on the resistors. That's unfortunate. This cap will need to go. Try to clean those resistors and see if we have problems, but I can't. This battery's got to go. Yikes. That's coming out now. I've heard of leakage, but this is a little nuts. This is some of the worst battery leakage I've actually ever seen. And what is going on with this fuse thing? Okay. I will show you guys that here in a second once I get this battery out of the way. Oh, now I've done it. I got some solder on the tube. That'll come off. Oh, no. Didn't want to flick solder that far. Yeah. The whole backside of the battery's blown out. Okay. That's trash. Just inquiring minds and questions. What in the world is going on here? I've got a fuse soldered on top of a fuse, soldered on top of a fuse. Like, why did we do this? I may have to open the other one. I doubt that's factory, but that one's a little weird. This is some of the, I don't know if you guys can see it on these two resistors. This is some of the battery damage I was talking about. I'm going to see if I can clean that up. Get that out of there. We have our two tubes. This actually doesn't look, restoration-wise, like it's going to be too complicated. Clean some controls, swap a cap or two, figure out this fuse nonsense. I did get some... I'm going to pull this tube out because I did get some solder on the... Get the solder balls out of the way. Nothing looks overheated, damaged, burned. That's battery acid burns, but nothing looks... that's unfortunate. I've got some corrosion on one of the precision resistors, so we'll have to check that one, make sure it's okay. But nothing looks horrible. All right, well, let me get some cleaner out. We'll start cleaning this up. That's just going to be a little bit of washing and everything like that, so I'm not going to bore you guys with that, but I will bring you back once it's all cleaned up. Well, I found another component that I'm going to swap out just for reliability's sake. It's probably unnecessary, but these guys have a selenium rectifier. So this would be the rectifier diode that was in this meter. I'm getting about a 5-volt drop across the selenium rectifier. I have a bunch of, I have an entire wheel of rectifier diodes. So I will just throw in a new CR1 while I'm in here doing some other stuff. The other thing that I'm thinking about doing, and let me know in the comments below if this is a good idea or a bad idea, they make battery eliminators for these meters, and I do have a line cord that's open, so I can put a circuit in this battery clip that'll provide it's essentially a 5-volt buck converter, rectifier and buck converter, that'll drive the ohms range without a battery, and it will forever eliminate that corrosion problem. The corrosion got pretty bad. I've got the 6500 turned on, and I'm going to check these precision resistors and things like that, just make sure the corrosion didn't get too far and destroy some of the divider resistors, because if that happens, I'll have to order some divider resistors to get the accuracy correct again. Haven't replaced any caps yet. I was going to tackle that rectifier first, so we'll get that thrown in. Then we'll do the caps. Then we'll at least be able to power it up and see if the meter movement works or if we're wasting time trying to bring this one back. So let me get a diode out. We will get that installed in circuit. Do the bulk cap. Do this cap down here. Bulk cap up here. Let's see. other oddities that are on this thing? Oh, yeah. Ceramic trimmer resistors. So this is for the balance, the DC and the AC control, or the calibration. This is a ceramic, it's a three potentiometer ceramic adjustment. So that's something you don't see every day. Oh, and this rectifier was in the B+ line. This is the B+ transformer. So I've got line voltage coming in, high voltage coming out, plates coming out. The selenium rectifier was in the B+. So, and this is probably the bulk can for the B+, just giving the layout of, or the topology of the board. What's our tube complement in this? We have a, well, they may be original tubes because they're both RCAs. 12AU7 and a 6AL5. Cool. So, first up, let's tackle this diode. Okay, our new capacitors are in here, and we have a new bulk cap up at the top. I had a, what did we put in there for a bulk cap? 22 microfarad at 400 volts. So, these will never go bad. Probably again, that'll be there for the life of the unit, which is the goal. Did notice I forgot to clip something. Test lead, or component lead. All right. So, repair-wise, I think we're good. Let's flip it over. We'll hook it up to the current limited supply and fire it up. Oh, our diode's hiding back there in between the red lines for the half-wave rectification. And let's go. All right, so if we have signs of life, what's going to happen is the needle meter is going to move and then come back as the bridge circuit settles. So let's see what happens. It helps if I turn the power on. So I'm going to turn the current limited supply on now. No smoke. We have a on light, which is good. I see tubes lighting up. We're warming up. There we go. And back down. All right, so we have some signs of life. Obviously, we are, oh yeah, I can zero the meter. The meter movement actually seems very healthy in this one. So, next thing to address on this restoration is, let's take care of this meter face. Let's see if we can't buff it out, make it look nice again. So I'm going to let this bleed off because this does have tubes in it, so there is high voltage. But I'm good with that. Okay, the camera's not doing the damage to this meter face much justice. There it is, a little bit, if I get the light just right. I hit this with the buffing wheel really quick so you can kind of see the light scratches buffed out really quickly, but it's got some deep scratches. We have a solder burn here that has just hit this meter over time. So what we're going to do is, I do want to clean this up as best I can, so we're going to really get aggressive on this. I typically don't go this far with meter faces, but I'm going to get out some memory paper. I'm going to do some wet sanding. We're going to really clean this meter face up. I think it is going to come pretty clear again, because the yellowing on these meters tends to be a little bit of UV damage over time. If they sit in the sun, the plastic will yellow with the patina of age. Not necessarily a problem, but some people like the patina of age. Some people don't like the patina of age. I want to get the best measurements possible, and this was very faded looking on the meter. When I popped it off, the dial face of the meter actually is in really good shape. I thought the meter itself was faded because this was so cloudy. So it ended up being just the front cover, which is good because that's easier to fix. So I'm going to work at this for a while. This is going to take some time. I'm just going to turn on some music, run through the grits of sandpaper, and then I might turn the camera on while we're going through some of that process just to kind of see what it looks like. But we're just going to be buffing plastic. Well, after sanding and buffing, which I do buff wet with some distilled water and some emery paper, we go all the way up to 2,000 grit, and it looks like crap. But you actually can't tell how well it's going to come out until it's buffed with a buffing wheel. So just doing it with sandpaper and and even going up to the grits still doesn't look like a window. So I'm going to take this over to the drill press. I have a high-speed drill press in the lab, and right now it's got a buffing wheel on it. We're going to buff this out, and it'll clear up real nice for the meter face. Okay, after buffing, it looks a whole lot better. So there were 2 deep scratches that I wasn't able to remove. We had the solder burn here, and we had this divot here. So what I'm going to do now is get my lens cleaner. One of the worst things to do when you put together monitors or anything like that is to get fingerprints under the glass, because those are impossible to clean once the whole thing's assembled. This one wouldn't be too bad. Touchscreens are a pain if you get fingerprints under the glass after you put them all back together. Okay, so we have a mechanical 0 here. I need to make sure that is pretty centered. It is. Now that needs to go in there. So that's what broke on that Simpson that I had to repair. But that pops in place, and that looks infinitely better than it did a while ago. Okay, let's check these resistors for some damage. Hopefully not. Meter's appropriately warmed up. And we shall set this to ohms. That is supposed to be a 130. That is measuring at a 139K. That is 138K 1%. So, is that in spec? It feels like it should be in spec. We are in spec at the high side, but that is okay. Spec's actually really tight on these. These are 1% resistors, so that's going to be fine. Let's check this other one. This is a 320. Meter will take a minute to settle down. That's actually out. Let me check 4-wire, see if it's actually out or not. Okay, now I have a quandary. I think I'm going to leave it, but what's going through my head right now, since I've been asked to talk about some of this, is this is one of the precision resistors that's that was set by the factory. And true, it is mildly out of specification. 320 ohm resistor. On the max I should have 323.2. I'm at 324.8. So I'm off by about 1K? 800 ohms. But the question is, should I change it or not? And I'm leaning to, if the meter calibrates and tests okay, leaving this in circuit. The reason being is sometimes these resistors were hand-picked for their ratios, especially because this is in the divider circuit. So as long as everything's working, I really don't want to mess with this, even though technically it's out of specification. I did also look at putting a battery eliminator in here. The problem with the battery eliminators is on this one, the filament circuit is, one side of the filament circuit's grounded. So it really needs the floating power supply from the battery. So what I'm going to do is, given that the makerspace where this is going to have a significant amount of time before they are ready to receive some of this equipment, I don't want a battery in here, sitting here, cooking, doing what happened again. So I'm going to leave the battery out. This means I won't be able to calibrate the ohms range, which is totally fine. Everything else in the meter will work, and it won't be affected. Also, some of the other equipment that I'm giving them, they'll have ohms measurement capabilities with other meters. So not having the battery in here is going to be a better solution than having the battery in here and having it blow up again. Where we're at now is I have to warm up the warm up the calibration gear and see if we can't calibrate this meter. There is a specific in the RCA manual, if you have to replace the tubes, there's an aging process before you should even calibrate this meter. The tube should be aged, hyper-aged, 24 hours, or the meter should run for 3 to 4 days with the tubes in with the fresh tubes in circuit before a calibration is done on it. I think that's for, well, that would be for long-term stability of the calibration as the tube ages very rapidly, and it's when it's fresh, this puts it into an area where it's kind of, some of its gain has fallen off in the beginning, but now it'll sustain this gain for quite some time and have a good long-term turnaround. So I'm going to put him back in the case because I think we're ready to power it up. Well, we've powered up already, but I think we're ready to continue with the alignment and see if we can't get it aligned, and then also sanity check the front panel for just accuracy. And if accuracy isn't affected, I don't think we're going to mess with the precision resistors. Okay, so we are on the unlimited power supply. It is hooked up to the mains. Ohms range isn't going to work. Oh no, wait, that's DC. Actually, we need to turn this off first, because what I'm going to do is I'm going to leave it set on the 5-volt range. I'm going to hook up some DC to it from my power supply, and I'm going to just let it measure 3.5, 4 volts for a couple hours and just make sure the meter's healthy. It's not going to smoke out or anything on us. So we'll do some long-term reliability testing. For right now, you guys are off to the side. I am dead on the front of the meter. We're going to zero set this right there. So the way, this was in the HP manual for the 410B. You zero set the meter, but then you back it off slightly so the meter's not resting on the zero set. And I like that. A lot of manuals don't say to do that, but I've started doing that because it seems like a good idea and to true up the measurements a little bit more. So we'll set this to DC volts. And as the tube warms up, there we go. Now we're coming to rest a little too low, so I need to zero set, because we mechanically zero set the meter. Now I need to zero set the bridge, which is there. Now I just need a couple of probe leads. All right, we're going to set this to 4 volts, because I want a decent deflection, but I don't want full-scale deflection. And we're going to set for 5 milliamp. Well, our DC is way off. No surprise there. We will need to calibrate this. Also, the DC is going to be pretty far off because of the voltage drop over the rectifier. So this is going to cause the range to be very much out of spec until it's adjusted, because of this has a 5-volt drop over the selenium rectifier where the diode has a 0.5 volt drop, so I have the B plus is running higher than it was before. Not going to be a problem. It'll calibrate just fine. We just need to do the alignment and the calibration. But that did translate to about a 0.5 volt error on the getting everything in balance, so that's not necessarily a problem. Okay, well, I'm going to let this sit here for a while. We're just going to monitor this. It's drawing 690 milliamps, roughly about 8 watts, 7.8. And we're just going to let this cook and then go from there. I'm getting a lot of questions about the isolation supply, the current limit, and how I'm doing some of this metering. I will have a video coming out on that in the near future. Okay, Well, I had to refresh the anti-static coating on the plastic meter because the meter face was moving around as I was moving my hand in front of it. It is not anymore, so we are good. However, I've got this set up to do the balance adjustment, and the balance adjustment is way off. So if I zero it on AC ohms, the mechanical zero is done. The meter zero needs to be done, but if I go to negative DC volts and positive DC volts, well, negative DC volts, we're way off. So we need to adjust this for zero movement when switching between the ranges. Now the balance is off because of swapping out that rectifier in the B+. It changed the B+ level. All right, let me do this with a good angle, and I'll bring the camera back. And with the balance readjusted, we're on plus DC volts. There's minus. There's AC volts. Could use maybe a touch more adjustment, but it is good enough to stay zeroed. Okay, I'm just waiting for the gear to finish warming up, but the accuracy of the DC range will be a lot better than the calibration document. The original calibration document says to use a 1.5 volt battery and adjust it for over the scale. So we don't necessarily need to do that. We're actually going to do the calibration on the 50 volt range because I have a 1000 volt DC reference here in the lab. Also, going by the calibration document, it has a fairly brute force AC calibration, which will do far better here in the lab. They want you to AC calibrate it off the mains and set it to 117 volts. Well, that doesn't work today because my mains are running at 124.6. So, what we're going to do there is we'll find a good range, maybe 120 volts, and I will use the AC calibrator at 60 hertz, 120 volts, and we will adjust it to the AC reference. I have that warming up as well. Those are the only alignment adjustments for this particular unit. So one DC, one AC, and the balance. That's it. So calibration on this is very quick, and as we can see, the effectiveness of the anti-static works well. What that check does is, if static builds up on the inside of the meter face, the meter will deflect and hang there. So that is a static buildup on the plastic surface and needs to be corrected for the meter to be accurate. Okay, well, the DC reference is happy today. We needed 47 volts. Let's see, 9, 2, 4, give it a little bit more. And we're off by about 70 microvolt, which isn't bad. So, let's see, we need to be on the 50 volt range. Right there, DC plus. Move this over so my leads reach. And I need to adjust the DC pot for 47 volts. So, we go into DC. And there's 45, 6, and 7. But I have parallax error, so I'm going to move the camera. And there's our 47 volts. Way more accurate than that would ever be in the field. So now it wants us to do, I'm going to do 120 volts on the 150 volt range, but we're going to use the AC frequency standard for that. So let me switch over the 7510, get the AC standard set up, and then do the last adjustment point. Okay, let's move our signal up here. We've got 115 volts on the test leads. Not going to short anything out at 60 hertz. So for 150 volts, the 150 volt setting, we need to read from scale B, which is this one. And I need to set for 115. But to get a more accurate reading, because this would be 150, I want to drop it back to 110, so we'll be right here. So I'm going to reset this up, test it for 110, and we'll do the adjustment on that setting. Okay, we are at 110 volts AC with 3 zeros of accuracy. So I want to be right here on this 11 because I need to multiply the B scale by 10. This is the R4 out of the VTVM that I'm measuring, and we are out of specification. That should be a 20 megohm 5% resistor. We're at 21.079, so it actually did fall out. This is actually a critical resistor. Due to modern manufacturing, I was able to get some 1% with not a lot of trouble from Vichy, and they're on their way. I did need to use the SMU to measure this because my 6500 DMM 6500 was kind of struggling with this barrier with this much higher than normal resistance. And just to make absolutely sure, we did it on 4-wire measurement. So, yeah. This is a coupling resistor between the rectifier tube and the voltage amplifier tube. So, yeah, it is a critical part, and this one does need to be right, but explains why I was low on all the AC ranges. It didn't matter how I tested it. I will get a schematic when we put this all back together, make sure this is the only fault, and then go from there. I did check the other meter as well, just off the chance that I had a this may or may not be a problem, and it also gave me the exact same AC readings. So I have a sneaking suspicion the R4 has drifted in that one as well, and that kind of leads me to think that the battery may have grenaded in that one also. So, but time will tell, and we will see. So for now, I'm waiting on the UPS guy, but for you guys, it will be half a second. Well, I had to wait quite a while. This was about 5 days in the mail, but our coupling resistors are in. So I've got the standards warming up. They're going to take a long time to warm up. We'll throw this in, do a quick check just to make sure there's no other problems with the unit, and then we will wait for the standards to warm up because that takes about an hour and a half. These are 20 megohm, and they are 1% resistors. The other ones were 5%, so that should actually tighten up the AC calibration a little bit. Won't do anything to the DC because this resistor is not used in the DC, but we'll see what happens. Okay, we have our resistor in, and I have cleaned the board around the resistor. This is starting to get into the realm of where the impedance is high enough that fingerprints start to matter, so I definitely wanted to clean up around the solder joints in the resistor really well. But that's all done, so let me throw the meter back in the case, put a couple of screws in, fire it up, and let's see what it says on AC. Okay, the meter's in, and it's turned on. I'm letting it start to warm up. Just checked balances, DC plus, DC minus, AC volts, so the balance is actually still pretty good. I didn't expect that to change with that one resistor we popped out, but since the AC calibration is 100% pegged, we are going to put 100 volts at 60 hertz into the front end. What I'm actually looking for is above 100. So right here at the 10 on the B scale, I want to see above that. If I get above that, we're good to go, and I just need to let the gear warm up. If I get below that, we have other problems. All right, that will do. We will be able to align and calibrate this. Fantastic. Okay, so I just got to let the gear warm up, and then we can dial that in, and then we should be good to go. Okay, we have 47 volts with 4 zeros, which is well good enough for this VTVM, and it's looking pretty good. There's a little bit of parallax error in the camera, so I'm going to get right on, just do the adjustment real quick, and then we'll do AC. And there's 47 volts dead on, So what we're going to do is we'll do the AC alignment at 100 volts, and we'll kind of be done. Before we do anything, we are going to make sure we zero the meter. Do this for every range, just to make sure. We also have 100 volts AC with 3 zeros, so I'm happy with that. Let me get dead onto the meter, make the adjustment, and then I'll bring everybody back. And there we go, 100 volts on the AC range. I'm going to add that to the list of replacements for the next meter, so hopefully the troubleshooting won't be near as bad. I did check the tube, and the 6AL5, the rectifier tube, was fine. There was no problems with it. It ended up being this capacitor. Ceramic caps typically don't go bad, but this, for whatever reason, floated out of value and was very lightly coupled, which also explains why when the meter was cold, it would be overvalued, but then when it warmed up, it would fall back. So, and this is one of the critical caps in the AC line, but doesn't affect the DC. So I'm going to double check the DC, but then if the DC is fine, should be good to go. AC is now calibrated. We are right at 100 volts. We're on the 150 volt range, so we have to use this 10 right here and multiply by 10. So that is reading 100 volts exactly like it's supposed to. And here's our 47 volts. Everything is good to go. Okay, well, here's our dish of shame for this particular project. We have a selenium rectifier, which wasn't bad, but needed to go. These other parts, however, these were bad. So this ceramic cap died. This cap was definitely bad. Electrolytic was dead. And as a surprise, that resistor floated up out of value. So all in all, not too terrible. But for those that would like a deeper dive into what's going on here, I'm going to pull up a schematic, and we'll talk about that for a little bit before I sign off. And here we go. So what ended up happening, what went bad in this one was around this 6AL5, which is being a rectifier for the AC signal before it goes into the DC amplifier and then out to the meter. So what ends up happening is your AC signal comes in here through some switching networks. We have a couple of attenuator resistors here that can get switched into different ranges, but we were consistently low on all ranges by about the same amount, so it would not have been these attenuator resistors. Our AC signal actually pops out here at switch pin 12 and then couples through this capacitor into this rectifier. It then comes out of the rectifier from this side of the plate here, so it goes into the first plate, cathode's grounded, but it also goes into plate and cathode, and then this one comes out. This cap seemed to be okay. This resistor was bad as well, so it was this capacitor and this resistor was what was causing the AC range to be off, and then that goes into the grid of the, let's see, after going through some more attenuators, it comes back to the grid of the 12AU7 to get into the DC amplifier, but it's DC at this point. So, but that is what was going on. We weren't getting enough signal through this capacitor because its value was off. Also, it was like covered in wax. And after really looking at this unit, when I had it taken apart, because I had to almost pull the whole meter face off and do some major surgery to get to this capacitor. Someone's been in there before, because a whole bunch of these resistors had been changed. So there was a lot of modern components on the range switch, which is interesting to note. So that is where we are at. This particular unit is ready to go back to the makerspace down in Greeneville. I will add this to the makerspace playlist. So if anybody at the makerspace in Greeneville is curious as to what went into make these units work again, the whole playlist will be there, and you'll also find all of the equipment at the makerspace for use in measurements if needed. As always, I will see everyone in the description below, in the comment section below, in between videos. More is always on the way. I do read all the comments, so if you guys have a comment, question, or concern, let me know. I may not be able to respond to everything, but I do read everything. As always, if you're finding this content interesting and entertaining, hit the subscribe button, and I will see everyone in the next video. More is always on the way.